Hello, I am G. Nagalakshmi, roll number 16. This assignment 1, problem P2, a current matrix builder. Um, Show the corpus and organization. First, I define the input corpus and the corpus contains several sentences related to computers and systems. I convert the corpus to lower grade and use regular expressions to tokenize it into individual words. Corpus is equal to corpus lower tokens D final this corpus. Then I count the frequency of each word and build the vocabulary using the minimum count parameter. So bull vocabulary, explain main concurrence function, scroll to define bull concurrence. Say the main function is bull occurrence. It takes the corpus window size, minimum word count, stop word option, and the well as input. For every target word, I look at the words within the selected context window. For example, when the window size is 2, I consider up to 2 words on each side target word point to left to maximum 0 position minus window size right main. Then every target context pair is counted, and finally I convert this count into CSR sparse matrix. So matrix CSR matrix, then using a sparse matrix avoids storing large numbers of zero values. Show the run experiment function. For every experiment I measure the matrix shape, the number of non-zero entries, density, concentration, time, and peak memory uses. Point 2, matrix minimize, calculate density time counter terminus mean. Density is calculated as the number of non-zero entries divided by total number of matrix entries multiplied by 100. Show the 4 window sizes. Run Python P2 current span compare. Show the terminal output. The assignment requires in experiment with window size 1 to 5 10. So I use the compare option to run all the experiments automatically. For each value of k, the program points the matrix shape non-zero entries, density, bold, time and peak memory. To show the comparison table, show the get top context and print context functions. I also calculate top based on the occurrence counts. I touched at least 5 query words, computer interface, system, user and response. Show the output. The contexts are sorted according to their raw coefficient top of the term. Despite each query word, the PDF specially requires 10 context, 5 every words. Show the density floor. Show the graph. I finally flowed against window size. As the window size increases, each word can interact the some more context words. So the number of non-zero entries generally increases and matrix become the answer point to float density results. Compare line options. Show our pass arguments option. This program is comparable from the command line. For example, I can change the window size minimum count to stop word removal. They serve to modify the source code. Show code. It's one example Python P2 PY Windows